Hello, my name is Brock Townsend, and today I'm going to be discussing acid and bases section of the ACS final study guide. This is question 2 on page 30. The question is, which is the strongest base? So there is 4 options available for this question. Each of the potential answers involves a benzene ring, but the difference is the groups that are attached and what is going on with each structure. So this first one, we have option A. This is a CH2, NH2 attached to a benzene ring. For B, it's NH2 attached to another benzene ring. It's a NH2 and NO2 attached to a benzene ring for option C. And for D, it's NO2, NO2, and NH2. So there's a lot of similarities, but a lot of differences in each of these potential answers. So when looking at this, my first thought was, well, what's the first thing I need to do? So the first thing I did was I wanted to pinpoint where the lone pairs of electrons were going to be, because when looking at amines and basicity, there's one factor to consider, is that the lone pairs play a factor in determining the basicity. Because if you have a lone pair of electrons on NH2, which is directly attached to a benzene ring, then this can directly affect the resonance. So this will play a role in the resonance structure, and this will be not as willing to donate the one pair of electrons for the reaction. So when first looking at this, there's 3 options that have the NH2 group directly attached to the benzene ring with that lone pair. And so if you would do the resonance structure of each of these 3, you would see that the lone pair of electrons would play in the resonance, and thus making it a weaker base. So taking this a step further, if you look at options C and D, for the basicity of amines, the more withdrawing groups you have, the less the basicity is decreased in this reaction for each of these reactions. So there is withdrawing groups on both C and D, thus making these not the best answer for the strongest base. So these would be weaker bases. And then when you look at option B, this is the NH2, it's directly attached to a benzene ring. So this lone pair of electrons would directly play a part in resonance. Thus, this would not be a good option, and it's not the correct answer. So the only correct answer that this could be, due to this effect of the lone pairs and withdrawing groups, would be option A. So option A is the correct answer, and this is due to the lone pairs and the fact that there is no withdrawing groups present on this molecule. Thank you.